So as I say, you're all very, very welcome. My name is Liz Woodham, and I'm a member of the NRICH team. We're based here in Cambridge, and I'm joined this afternoon by Claire Metcalf, hi Claire, and by Ems Lord, hi Ems, and the three of us will be working together to take you through this afternoon's webinar. As you know, the idea of the afternoon is to share with you some of our most recent primary problems. So we're going to be working on some maths together, and we're going to be thinking about what the tasks look like in the classroom, how they might encourage learners to think mathematically. Various points we might ask you to contribute using the chat, so please do if you feel able. And don't worry if you're, it's not a fully formed answer that you are about to type in. We would much prefer you to type a starting point than nothing at all. We're very grateful to Trinity College here in Cambridge, who fund these series of webinars so that they're all free of charge to you. There will be the recording that we're making now will be available on the NRICH website early next week, and we'll give you the link to that later on. So I think we ought to get going. Basically, what I'm going to do is introduce you to the latest feature on NRICH, and Claire and I will have a bit of a conversation about some of the tasks. I might ask Claire to have a go at some of the maths, but please do, as I say, participate yourselves using the chat. So I'm going to share my screen so that I'm hoping you're going to be able to see the NRICH website. Claire, could you nod at me, please, if that's all? Brilliant. Okay. So here we are. We've got the homepage of NRICH, and as we're focusing today on the primary resources, I'm going to go to the primary teacher homepage. I could do that using the links in this green box, but often the easiest way is using this button because this menu stays on all pages of NRICH. So I'm going to click there, and on the right-hand side, we're going to focus today on our latest feature. So I'll click that. So as you can see, we've got a feature that focuses on outdoor maths. We're hoping that by taking maths outside, you can offer a different kind of motivation for some learners, and we're suggesting that you can think mathematically outside through a number of different ways. So one way, for example, would be to create your own maths trail or a maths walk, perhaps, but for slightly younger children. And if that's the kind of thing that you'd like to explore, you'd like to have a think about, do read this article here that's written by Becky Mosley, who is a colleague in the Cambridgeshire Learning Team for the local authority here in Cambridgeshire. And what I really like about her article is that although, of course, it's set in Cambridge and Peterborough and the surrounding area, there are various versions, she outlines some key considerations. So she's looking at creating a maths trail and the kind of things that you might like to bear in mind as you create a trail in your own locality. For example, they focus on encouraging problem solving. They focus on the idea that they don't want the mathematics to become out of date. So thinking about a stimulus which is not going to disappear if the trail is done 3 months down the line. So do read that article at your leisure if that's something you're interested in. So a maths trail or a maths walk is one way of engaging learners in outdoor mathematics. Another thing that you might consider doing is creating a visually appealing outside space that encourages mathematics. Now, that can be done in all sorts of different ways, and it might look different for different age groups. An example of that I'd like to share with you very quickly is this obstacle course activity. Now, as you can see, this is one of our early years tasks. So it's aimed at young learners. And don't worry, I'm not going to suggest that you get up and start crawling under your sofa or anything like that, but I'd like to give you a flavour of this task. Our early years activities are all set out in a similar way. And it summarises here that this activity is about setting up a simple obstacle course in your environment, and trying to vary the kinds of activities that you might encourage the children to do. So this idea of balancing, going through things, crawling, going over, under. if I scroll down the task, you can see that we're offering some different prompts to encourage learners to think mathematically. These headings are the same in all our early years tasks, by the way. And you can scroll down to give a summary of the kind of mathematics that children might encounter as they have a go at an obstacle course. And there's some ideas for variation. So this is obviously this is just one particular example of how you can encourage some mathematical thinking by, carefully considering your outside environment. What can you do with the outside to encourage children to do some mathematics outside? Just before we move back to the main feature, I'd just like to share with you our children's thinking section. Now, I've clicked on the early years homepage. I'm going to scroll down to this red box. Here are some examples of children's thinking. Now, if you're familiar with NRICH, you may know about our live problems that we ask children to send solutions to. This is sort of an early years equivalent, sort of. We have a practitioner in the Northwest who has helped us develop this obstacle course activity. And here she outlines some of the things that the children did, said, thought about. We've included a few video clips here as well, but they're not all video clips. It gives you a little sense of the kind of things that she noticed the children engaging in and she was able to encourage. So do take a look at that, or let your early years colleagues know. Right, let's go back to our feature. Actually, a quicker way, I think, is going to be to press the primary teacher's homepage button again. And here we are. So back at our feature. So,
just to add one thing about the maths trails, what Liz said about making sure that they don't go out of date is incredibly important. So we did one of the, there's a company called Treasure Trails, and we did one around Newmarket. And one of the questions was about how much would it cost to park? But unfortunately, Newmarket put all their car parking prices up. So that kind of ruins that question. So do try to use things that aren't going to go out of date very quickly.
Exactly. And Becky in her article outlines all sorts of, ways you can do that relatively quickly, but just bear it in mind. Yeah, thanks, Claire. So you've got the maths trail, you've got creating an appealing outside environment for children to engage in mathematics through their own play, for example. And then the third way that we think that you could develop children's mathematical thinking outside is by using an aspect in your environment to deliberately focus on a particular area of mathematics. Now that's what we're going to focus on in this afternoon session. We've got several tasks here, which have all been stimulated by, that's perhaps not quite the right word. They've all come from something in the environment or a context that has sparked our imagination to put together a mathematical task. And in every case, I'm sure that you could think of your own examples too. We're going to start with the street sequences task. I've spoken for far too long. Let's do some maths. I'm just going to make this slightly bigger so you can see that picture. Okay, here we go. 2 front doors, a picture. What do you notice about those front doors? Do pop your noticings in the chat. Don't worry if you think it's really obvious and everybody else has noticed it too. Do contribute still. What do
helps us to know that you're still out there.
Yes, exactly. Lovely. It's really interesting with a task like this, isn't it? The colour kind of leaps out at you, and children will talk about the colour, and it's important that we acknowledge that, yes, those 2 bright colours are really noticeable. We might like different door handles. Lovely, yeah.
I'm wondering now if the 2 letterboxes, how different the 2 letterboxes are in colour, or whether it's the background colour that makes them look really different.
That is interesting, isn't it? Because the letterbox on the yellow door does look more silvery, doesn't it? But is it affected by the yellow colour? Interesting question, Claire. And I like the way some people are comparing the shape of the letterboxes as well. I'd like to draw our attention to the numbers that are on the doors. We've got 31 and 33, and some of you noticed this too. Some of you mentioned the fact that these are both odd numbers. Now, of course, depending on the age of children and the experience of the children you're working with, at this point, you will be focusing and questioning in a way to suit them. So for younger learners, exploring the oddness and thinking about, what would the number of the house the other side of the yellow door be? These kind of questions to tease out the pattern will be really important. I'm going to assume for us here this afternoon that you're really happy with the fact that we've got odd numbers on these doors. Let me just go a little bit further down the task. Actually, I think I'm going to leave it blown up like that. So the street where I live here in Cambridge is very much like that. It's got lots of Victorian houses on it. And on one side of the street, there are odd numbers. And on the other, there are even numbers. You'll see on the screen now a quick mock-up picture of what the odd numbered side of the street could look like. Just to get a sort of an overview of the whole street, what we've got here underneath is an image, like a plan image, if you like, of just the numbers. So I appreciate at this point, you may have to do more work with helping children interpret this image, but I'm hoping that you can get the idea that here we've got a representation of one side of the street with the odd numbers, and here we've got a representation of the street with the even numbers. So I'm imagining walking down this street and we're going to start adding the numbers in a particular way. Have a look at this image now. What happens if we add the numbers across the street in pairs like this? So let's have a look at the first one together. If I add 1 and 4, I'm pretty sure I get 5. Claire, what do you get if you add 3 and 2?
I get 5.
Right, okay. So we've got 5 and a 5. Let's move on to the next pair here. So if I add 3 and 6 together, diagonally across like that, I think I get 9. Claire, what about 5 and 4?
I get 9 again.
Okay, so over to you now. Have a go. What do you notice? Have a go at some more pairs in that same way. What do you notice? You might notice, several things. Don't limit yourself necessarily. But crucially, can you begin to explain why your noticings occur? So do post on the chat. First of all, please do post up anything you notice, and then we'll dig deeper a little bit to think about why those patterns occur. Okay, I'll give you a few minutes. I see that Scott has suggested that the answer is always odd on the top row. Scott, I wonder, I'm just thinking about what we might mean by the top row.
I think it means that the top row of house numbers. So when we look at the first 4, we always get an answer of 5, and 5 appears on our top line of house numbers.
Oh, I see. Thank you, Claire. I hope that's what you were thinking.
So perhaps you could ask students, would it be possible to ever get an even number by doing like this?
Lovely.
And somebody's also said every time you move up 1, you increase the sum by 4.
Yes. So we've got 2 noticing so far. I apologize. I haven't read all the messages yet, but so far we've got a noticing that the sum appears to always be an odd number. And the noticing that as we go up in our pairs, we seem to increase the total by 4. So yeah, Scott. Okay, thank you, Claire, for interpreting.
That's right.
Scott is affirming that that's what he was saying. Okay. Anything else? Let me just have a quick check. Difference of 4, different. Yeah, so the difference of 4 has come up quite a few times.
I mean, one question that hasn't been perhaps noticed is that whenever we have this cross pattern, are the sums always the same? Oh, right. Somebody's just put that in now. I said that.
Just as you were saying, brilliant. So that, I think that makes 3 noticings. We've also got this idea that our diagonal pairs produce the same total in our little group of 4. Fantastic. So and there might be other things that students point out, which I guess if I was doing this in the classroom, I'd be giving students time to have a think about this in pairs, and then maybe there would be an opportunity for us to share our initial thoughts. We might write up some ideas, and then we might decide to focus down on 1 or 2 of those noticings. Mathematicians love noticing patterns. I think it's that idea of wanting to have order and structure. But a mathematician is not satisfied just with the noticing of the pattern. A mathematician wants to know, why does that pattern occur? Does it always occur? I doubt that there's anybody who has checked every single little group of 4 numbers there. Perhaps I'm wrong, so perhaps I shouldn't say that. But even if we had checked all the numbers on this street with houses of 1 to 30, can we be sure that that pattern will always occur?
Can I drive for a bit at this point?
Yeah, please do. Please do.
I'm just going to try and share my screen. Okay, so I've just got a picture. These are called algebra tiles, and I'm just going to take away the labels because we don't actually care about X's and things at this point. If we think about 4, I'm just going to try and annotate over the top. If we think about 4 house numbers, for example, we could have 7, 8, 9, 10.
Yeah.
So any group of 4, I think I can represent these 3, sorry, from the first one.
Ah, interesting. I wonder if on the chat, could you see how Claire could do that? How might you express the 4 numbers that Claire has put a box around?
3 numbers.
I beg your pardon. 3 numbers that Claire's put a box around. How might you express those in terms of the 7, I wonder? Can anybody think? What connects the 7 to the 8, or the 7 to the 9, or the 7 to the 10? Okay. Right. Nice. Thanks, Christina. Thanks, Emma. Yep. Sorry, Claire, I interrupted you.
Yeah, no, that's okay. So we can represent this by using these algebra tiles, but kids might like to think of them as being bar diagrams. And we can build up a picture to show what these house numbers look like. So I think our picture looks something like this. Really? Taken a slightly long time, but
no, that's okay. It's helpful when you do it, because you're building up the picture gradually is actually quite helpful. Okay, so what we're saying here is the green block is representing, in our case, it's representing 7.
7, yep.
And then the yellow is representing a 1.
Yep.
So we're saying the 7 plus 1. And then we've got the 7 plus 2. Yeah, nice. Lovely.
But that green block doesn't have to be 7.
Absolutely.
It could be any starting point.
Absolutely. So Claire, how I think this representation might really help us. So in the task, we were adding together diagonally opposite numbers, weren't we?
Yeah.
So I guess in your example here, we're adding together the 7 and the 10, but as you say, the green block could represent anything. So I wonder how could we show that adding together, perhaps?
Okay, so to show the adding together, I think we want to add up, I'm just going to move this one out of the way. Oops, I thought that was going to work nicely.
Oh, that's a shame.
No, it doesn't. That's a shame.
Never mind. Never mind.
We will have to ask Oscar to create one of these for us.
Okay, so we've got green at the top, and then we've got the 3 more than green.
And we want to add together.
Yeah.
And then along the bottom, so we want to add those two together, and then on the bottom we want to add these together.
Yeah.
Now to me that's not quite satisfying yet.
No, I'd want to line them up really carefully, Claire. Yeah. Okay. Now that's interesting. You've gone a step ahead there, Claire. I noticed that you pushed the 2 greens together. Mm-hmm. I guess learners might initially put the green and the 1, and then, yes, don't worry. Yeah. I know. Poor you having to move.
That's right. No, it's okay. I can do that. Yep.
Lovely. So that convinces me that those 2 totals are the same. And as you say, the important point here is that we've not just represented 7, 8, 9, and 10, because the green block could be anything and the yellow is representing 1. Actually, this could be any 4 consecutive numbers, any 4 in this block on our street. Very nice. Okay. Now, that's one way. What I love about that is that visual image. And the fact, as I say, that it's generalizable.
Yes, and you can also use this sort of idea. So when I first saw the problem, I didn't read it properly, which is generally one of my failings. But when I first saw the problem, I instead looked at multiplying these.
Oh.
7 times 10, which is 70, and 8 times 9, which is 72.
Ooh, yeah.
But I think I can use my algebra blocks in a similar way to show that this works. But I won't do that now. I'll leave that as an exercise.
But how nice that we think that the algebra blocks could work in a similar way to prove visually, if you like, to reason through visually. I know that in the chat, some of you started to try and tease out using words why some of these noticings will always occur, and that's exactly the starting point that I would use with children. And even, you know, our very powerful image here, I think is really accessible even to younger children. And you still need some words alongside the image, but I think the image really helps. Thank you, Claire. That's brilliant.
Do you want to take control again?
I shall take control again. Thank you very much. Lovely. Let me go back to the website. Where are we? Here, there we go. I didn't recognise what the task looked like for a minute there. So here we are. Now, as Claire said, she happened to, when she first looked at this task, she happened to think it was talking about multiplication rather than addition. But I think one of the lovely things about this task is that your learners will come up with their own questions. Multiplying the numbers might be one of them. They might think about grouping the houses in different ways. Some streets have got the, you know, semi-detached pairs of houses together, and that might prompt some other kind of thoughts. So why not walk down a street near you, if that's appropriate, and see what your learners come up with that applies in your own setting. I'm just going to make this slightly smaller again now, just so that we can see the menu more easily. This is one of our live tasks in this feature. So if you have a go at this with your children, please do encourage them to send in their solutions. You can click here, the submit a solution link, or you as a teacher do feel free to summarize what your class has done. The main point to remember is that we're really looking out for well-explained solutions. Do make sure your children outline their reasoning, not just an answer. Okay, I think it might be time to have a look at another task. So I'm going to go back to the feature. Here we go, outdoor mathematics. Scroll down a bit. So that was street sequences. Claire, I'd like to introduce you to this problem, growing garlic.
Okay.
I'm going to make this slightly larger. There we go. The reason I'm going to make it slightly larger is because I don't want you to read all the question yet, Claire.
Okay.
So Ben and his mum are planting some garlic. They've got several garlic cloves, and Ben arranges the cloves into 3 equal rows, and he finds that he has 1 spare clove left over once he's done this. So the first question I'd like you to consider, those of you participating, please do consider this at the same time. Claire, I'm going to ask you not to say anything just to start with.
Yep.
How many cloves how many cloves might Ben have had to start with? And how do you know? So have a think, pop a suggestion in the chat, please. 3 equal rows, 1 left over.
We've got a couple of suggestions coming in.
A couple of suggestions. Claire, do you have one as well? I asked you to be quiet, very bossy kind of way.
Yeah. Well, I'm going to go for the smallest possible thing I can have. And I don't know if this is going to work, but I think I could have 1 row of 3.
Yeah.
And then 1 left over.
Oh, nice. I like the way you did that. Think about, the smallest possible. That's often what mathematicians do, isn't it? Start simplest first. We've got several examples, several suggestions, 110. At this point, I'd just like to scroll down a little bit and show you, Claire, would you mind? Thank you. I'd just like to show you the interactivity that one of our colleagues, Oscar, has developed, which is not a substitute for doing, your own scribbling, because that is so valuable. But what it does, I think, is gives you a sort of visual representation, which might be really helpful for children. There's still some unpicking to do. So I'm going to check out one of these suggestions. Somebody has put 10. So I'm going to put 10 in this box here. That's the number of cloves of garlic. And then here, we said 3 rows, so there's 3 rows, go. Haha, so yes, there is 1 left over. Nice. And let's see, should we try one more? The most recent comment here I can see is 100. Okay, let's see, 100 in 3 rows, go. Look, they've scrolled all the way down. Let me just scroll down a little bit. And if I, oh dear, I don't take it off. Oh, now it's too big and we can't see it all. There we go, that's a bit better. I've got to carefully, so there we go. And I can scroll across. Yes, 3 equal rows and 1 left over. I wonder, so is there, oh, I can see that somebody has posted a suggestion. I was just going to ask, how might we express this? What numbers are going to work and how are we going to know? And somebody has suggested 3 times any number plus 1. That's really nice. We might say a multiple of 3 plus 1, or 1 more than a multiple of 3. And the reason why that's really helpful, perhaps, is it gives us a way of knowing whether a number that somebody gave us would fit this pattern. So if I said to you 52, you would be able to work out whether that could have been a number that Ben planted. Thank you. Yeah, and we could explain it. We could write it algebraically if we wanted to, but we don't have to. I think that the articulating the idea, a multiple of 3 plus 1 is absolutely great. It's that thinking, it's that expressing, not necessarily expressing it using algebra, which I think is important at this age. So I deliberately didn't want you to see the rest of the question, but let's have a little look at it. This now, obviously with our interactivities I've just shared with you, you as a teacher could use that for all sorts of questions of your own. You wouldn't have to type to garlic or anything. It's really powerful as a representation of factors, multiples, remainders in this case. So do play around with it and use it in whatever ways you'd like. But let's go back to the second part of this question, which is a little bit more challenging. So this time Ben takes these cloves of garlic and he plants them in 2 equal rows, but he has 1 left over. So he gathers them all up, he tries them again. This time he lays them out in 3 equal rows, and he has 1 left over. Not satisfied. Gathers them up, 4 equal rows, has 1 left over, and so on. 5 equal rows, 1 left over. 6 equal rows and 1 left over. Now we know he has fewer than 100 garlic cloves. I'd like you to just take a minute or so just to think about how many cloves Ben might have, if we know all that information. And what I'm really interested in actually at this point is how you're going about working it out. What are you thinking to? What are you attending to? So let me give you a minute to think. Do post in the chat, not necessarily your solution, your answer, but how are you going about working it out? What are you doing? And then Claire, I'll quiz you about what you might do in a moment. Okay, over to you again.
So as well as thinking about how you do it, you can also think about how your students might do it.
Absolutely. Thank you to those of you who've posted some suggestions so far. Sue, your comment is I think a really helpful one. You've noticed that actually, as we articulated before, we know that the number of cloves of garlic that Ben has is 1 more than a multiple of 2, is 1 more than a multiple of 3, etc. And you're sort of turning that on its head, which is really nice. And you're saying, so actually, I know that the number of garlic cloves must be 1 less than a number which is a multiple of 2, 3, 4, 5, and 6. That's yeah, as I say, turned it on its head.
There's a slight complication there, though, because if you do 2 times 3 times 4 times 5 times 6,
yes,
you don't get 61, which somebody else suggested.
Ooh.
So there's a slight issue happening there.
Oh, what's happening there? Some of you now. I want to make it very, very clear that the kind of things we're talking about now, you may well, your learners in the classroom may not approach it like this at all. We're immediately sort of extracting. We're thinking quite abstractly, very, very quickly. As Scott, I think it was Scott just said. Let me just scroll back into the chat. Somebody said, yes. Scott says some children might do each times table at a time. Absolutely, and that's great. I think the key in that case is what are they learning and what are they understanding each time and taking forward as they look at the next times table.
Liz, can you just reduce the size of the page a little bit so there's a bit of white space?
Of course.
Then I might be able to scribble down the side.
Yeah, of course. Is that enough?
Yeah, that's perfect. Okay. So I can't remember who it was who suggested it, but somebody suggested looking at 1 table at a time. And I think that's a really good problem solving technique, is to, okay, this is quite a hard problem. Can I look at a simpler problem and use that to gain an insight into how I can do the rest of the problem? So for this first one, you know that it's got to be basically an odd number. It's got to be a multiple of 2 plus 1. So you can write down, actually, I think I know what the smallest number is. I don't think it is 61. I think the smallest number is 1. But let's take away the smart answer.
Although would Ben have put any in rows at that point, Claire?
Yes, he's put them in zero rows. It's a bit of a mathematically yeah.
I think that doesn't take into account the context properly. I would say in the context of the task,
no, we
couldn't have one. Okay, so nice. So you're writing there.
So you could have these ones that satisfy the 2 rows.
Mm-hmm.
And then for 3 rows, we know it's got to be a multiple of 3 plus 1.
Mm-hmm.
So if I am ditching the 1, since Liz doesn't like it, I've got 4, 7, 10. So I'm just going to keep adding 3 now.
Mm-hmm.
And try to not to get it wrong. Okay. And so from this, they can start to see which numbers satisfy both. So we've got 7,
mm-hmm.
and we've got 13,
mm-hmm.
and we've got 19. My sausages are getting a bit long. We've got 7, 13, 19. And they might be able to spot a pattern now.
Mm.
They might be able to think, okay, well, the next one is going to be 6 more. And that might get them starting to think about multiples of 6. And they might be able to see that, okay, these numbers are all 1 more than a multiple of 6. Then they can bring in maybe the 4 ones as well,
mm-hmm.
and sort of build it up like that.
Exactly, yeah. Thank you.
That'll be probably how I would introduce it.
Yeah, I think that's a really nice demonstration that actually we don't, we can approach this. I mean, what you've done is it's very systematic, and so we can be sure that if approaching it this way, we're not going to leave out a possibility because you're being, as I say, so systematic about it. I guess taking a step back. Even some children might start just by trying a number, plucking a number out of thin air and thinking, okay, does that work? And I guess that's where the interactivity could come into. They could check their answer easily. They might, hopefully, they would begin to notice things from what the arrangements that the interactivity was giving them. So they would then become a bit more systematic.
I'd probably encourage them, if they're going to do that one, to, so let's say we had the number 21.
Yeah.
Oops, don't know where that 2 went. That's back again. It would be quite good if they, 2 rows, yes, that works. 3 rows, no, it doesn't.
Yeah.
And to actually consider which things don't work.
Absolutely.
To help them build up the connections.
Absolutely. Yeah. Brilliant. Thank you very much, Claire. And some of you, I think we didn't know, some of you have talked about lowest common multiples. Absolutely right. If that is mathematics that you have met already as a learner, then it would be great if you recognize this as a situation that it was applicable to. However, children, officially, children at primary school are not introduced to that vocabulary. So while it is something that some might have come across, we can't guarantee that. And actually, what is important here is about the understanding of the situation rather than happening to know that phrase and what it means, I think. And having that opportunity to explore using the interactivity combined with some systematic thinking, I think is what this task is about. I love the fact that some people are posting up possible solutions, which is great. They're still thinking about it. Claire, have you got anything else you'd like to say about growing garlic?
Not in particular. I mean, you can also perhaps create slightly different problems. So you could have problems where you've always got 2 left over. You could create a problem where one of these was missed out. So we could take out the 5 condition. You could have it, which I think I've seen at one point. He plants it in garlic into 2 equal rows, he has 1 left over. He plants it into 3 equal rows, he has 2 left over. Plants it in 4 equal rows, he has 3 left over, which is a subtly more difficult problem.
Yeah, thanks, Claire. Great. This is, let me just scroll up again to the top of this task. This is also a live task. So again, if you and your learners have a go at it, do send us their solutions. And you may find that some of them are published just before half term. So at the end towards the end of May is when we'll be publishing new solutions. I'd like to go back to the feature again. And we've got time, I think, to explore one more problem. Now, this problem is very much aimed at upper key stage 2. So while the other problems we've looked at, so, you know, obviously we've seen the obstacle course, which is very much for younger learners. Streak sequences, I think, is applicable across a whole age and experience range and can be tweaked accordingly. What we're about to have a go at is very much upper key stage 2. And it's a context which I predict that your learners might not have thought about at all. So I'm going to introduce you to this setup quickly. I'd like you to imagine that there's a tall tree at the edge of your playground at school. Unfortunately, it's diseased. And so there's a possibility it might fall down. Obviously, the caretaker wants to do something about it before that happens. But what we need to know is if that tree fell down, would the school buildings be safe? So the caretaker would like to be able to estimate the height of the tree to be sure, before the caretaker gets around to sorting out somebody to take the tree down, the caretaker would like to be sure that the buildings are not going to be damaged. So how might we estimate the height of the tree? I wonder whether you could have a quick think and post in the chat any suggestions you have. And don't worry if they perhaps sound ridiculous to you, and I also appreciate you may never have thought about this before. So just, be creative. What might you do? Suggestions in the chat.
This one is a very open-ended sort of problem.
Thank you to those of you who've made some suggestions. Absolutely. So I think a couple of you have suggested one thing you could do is get somebody to stand near the tree and then, look from a distance and estimate how many of them would need to stand on each other's shoulders, as it were. And if you know the height of the person, then you'd be able to estimate the height of the tree. Nice. Or, as Larissa says, you might be able to compare the height of the tree with the height of a building that you could measure, or researching the height of that particular type of tree. That's a good idea. So you might get a ballpark figure. Measuring the shadow. Right, Larissa, interesting. Now, what we've done in this problem, now, it's important to say that what we've included in this problem are just 2 particular methods. And at the bottom of the task, we invite children to think about other methods. Mo's method sounds a little bit like perhaps what Larissa might be suggesting. So Mo suggests that we should wait for a sunny day, and then we could measure the distance from the tree to the school buildings and measure the length of the shadow of the tree. And then if we push a cane into the ground or a stick into the ground, which sticks up exactly 1 meter, so exactly 1 meter is above ground, and we measure the shadow of that stick or that cane, then we should be able to work out the height of the tree. Do you think that's going to work? How do you know? I wonder.
Are there any problems with that?
Yeah. Let me give you a couple of minutes to consider. Is that going to work? How would you use what Mo is describing to find out the approximate height of the tree? Have a think. I appreciate that this isn't quite so easy to enter on the chat because it's a bit more. So don't worry if you don't feel able to put anything on the chat. Have a think, and then I'll show you. I might ask Claire what she thinks. If that's the right, Claire?
Yep.
Yeah, it's an interesting point. Shadows are going to be different lengths at different times of year. Does that matter?
I think that's okay. They're different lengths at different times of day as well.
They are indeed, yeah.
So I think you may have a time restraint. You probably can't sort out the cane and then 3 hours later look at the tree.
Right.
You probably have to do it at the same time.
That's a good point. So these are really good points that you're posting. Actually, yeah, shadow lengths do change. So if we want to be able to make a comparison, we should try and measure the shadows on the same day as close in time as possible. There's a question that Larissa's asking about the cane. Why 1 meter? Good question.
Does it have to be 1 meter?
Good point.
I would suggest that if you try and do 1 centimeter, then the accuracy of your measurement is going to cause problems.
Good point. Good point. Claire, what might you do then in this situation? How could we use? Is this going to work to give us an approximate way of finding out the height of the tree? Do you think?
I think it will work. So if we've got, so we can imagine a tree. It's meant to be a tree.
Nice.
And there's a shadow. And then if we have a 1 meter stick,
yeah,
we can measure, say that was 80 centimeters.
Yeah.
Then I know that every 80 centimeters across of my shadow, I get 1 meter of height.
Yes.
So if this was, I'm going to pick a nice number.
That's fine.
If this was 3 meters 20, I know that's 4 lots of 80. So I know my tree is 4 meters tall.
Nice.
Somebody's made a brilliant suggestion, which is we could stick our stick in and then we could hang around and wait until the sun is at the right time so that this is exactly 1 meter.
That's a fantastic suggestion, Sue.
Which
that
will
would make
our lives a lot easier.
Makes life a lot easier. We'd have to do far fewer calculations. And yet we still have to understand what we were doing. That's brilliant. I like that, Sue. Thank you, Claire. By the way, in case the way this question is phrased, it's we haven't given you any measurements, and it's interesting to see that as Claire tried this out, she used some measurements. She came up with some measurements to help her demonstrate how to use Mo's method. In the teacher's resources of this task, we have given a suggestion of some measurements just in case that is useful for your children to have a particular example to work with, which, as Claire's demonstrated, is often very useful. Brilliant. Thank you, Claire. I'd like to introduce you now to another method. This one, before having a go at putting this task together, I have to be honest and say I had not thought about this. The shadow I'd come across before. Sam's method. Let's see what Sam did. So Sam suggests that their teacher could bend over, look through their legs, but they need to do that at a position where they're just able to see the top of their tree as they bend over upside down and look through their legs. And Sam's suggesting that at that point, the distance to the base of the tree will be the same as the height of the tree. Now, if we had a bit longer, I'd invite you to think about that a little bit first, but let me show you this picture. which might help us unpick what Sam is suggesting. So here's poor Sam's teacher bending over, looking through their legs to the top of the tree. So the sight line is to the top of the tree. And Sam is suggesting that this means that this distance here from the tree to the teacher is the same as the height of the tree. Now, the key point, of course, here is this 45-degree angle. What Sam is suggesting, that if the teacher does this, they will be making approximately a 45-degree angle. I'm just going to to share something. I've got a piece of paper here which might help us just to scribble a little bit quickly. Can you see this paper copy of the yep. So Sam is suggesting that if their teacher does this, then this is going to make a 45-degree angle. How can we use that information, I wonder then, to convince ourselves that this length is the same as this length? Let me make a sort of a triangle here. We know this is 45 degrees, Sam is telling us. What do we know about this angle here, I wonder? Yep, thanks, Larissa, this triangle. Okay, right. So we're saying that, I mean, as near as we can possibly say, this is going to be 90 degrees. So absolutely, thank you. We've got an isosceles right-angled triangle, which means that we've got 90 here, 45 degrees here. That means we've got 45 here. We know that the angles in a triangle add up to 180. And therefore, we know, I'm going to use some notation which I don't expect primary children to learn to know, but just to make it clear, this length, therefore, is the same as this length. Yeah, so that's interesting. I never thought about that before. You may have come across that before, you may not have done. Claire, any comments about that?
Just say that this is actually a problem that I remember doing at school more than 30 years ago. And what we did is we made something called a clinometer, which basically measures angle. And I don't know if I can draw on top of this. No, I can't draw on top of that because that's a picture.
I can stop sharing. I can change my sharing. I'll go back to the website and then you have to scroll.
Then I might be able to scribble on top.
Yeah.
I just find it much easier to describe things when I'm. Yeah, there we go. We're back again. So what we did is we made something called a clinometer, and that enabled us to measure the angle from a certain point to the top of the tree. Here's my fairly rubbishy tree again. And then we drew a scale drawing, so we could measure this height, this length. We could measure. We knew the height of ourselves, and then we could use this angle here. So say it was 20 degrees, we could draw a scale drawing and work out what that height of the tree was. So it was slightly more, I think I did that in middle school. So it'd have been year 6 or year 7. So fairly high up.
Yeah. Thanks, Claire. I mean, as I say, we offer these possible ways to get into the problem, to think about it. If you have a chance to try this out with your learners, again, we'd love to hear from you. Do the methods work? Well, I guess, unless you've got a way to accurately measure a tree, we won't know for certain that the methods have worked. But if you use both of them, did they give comparable results? Were they very similar? And your learners might have other ways to suggest, as you did. Incidentally, that sheet that I had printed off there with the image on is available in the teacher's resources. So let me just quickly show you. You'll find a link to it here in case that's useful. So not only does it have the image of Mo's method, it also has the bit of text, Sam's method. It has the bit of text to outline what Sam was thinking, so that children could refer to that and scribble on the sheet should they wish. We are rapidly coming to the end of our session this afternoon. I hope that you've enjoyed working on a few tasks that have been inspired by the outdoors. I hope also that these are just a taster, and you will you'll be encouraged to take your learners outside and do some mathematics outside and create your own problems from your own environment. I'm going to go back to the PowerPoint very quickly, just to round up. There we go. Let me share it now. Thank you for being patient. Here we go. So we've really enjoyed working with you this afternoon, and if you don't already follow us on Twitter, do, because that way you will find out about our latest news. If alternatively you'd prefer email communication, do sign up for our email newsletter instead. Although we've focused very much on the current feature today, I just want to draw your attention to the curriculum page on NRICH, which kind of brings together all things curriculum related in terms of primary tasks, including our mapping document, where we link NRICH tasks to curriculum objectives. Do take a look at that. Particularly useful, I think, if you're relatively new to NRICH and you'd like some guidance about which tasks to try first. That's where you'll find all our previous features. As I say, we've just focused today on the outdoor mathematics features. Incidentally, these links you can all access from the primary teacher homepage as well. That's the URL where you'll find a recording of this webinar. As I say, early next week, I think it's safe to say. You can see that there, and then you can share it with colleagues should you wish. We really appreciate your feedback. Trinity College do ask to hear from participants, and of course we want to make sure we're doing as good a job as we can. So please do complete the evaluation form with your feedback. We'd be very grateful. And just in case you're raring to see us again, there is the link for the next primary teacher webinar, which we will be leading on 15th of June, another Wednesday. Do join us if you can. Thank you very much for participating. It makes our lives much easier when you post in the chat. Thank you. Claire, is there anything or Ems that I haven't said that you think I need to before we sign off?
I think that's covered everything. Just to reiterate, thank you very much for coming, and it's been really nice to do some primary stuff rather than post-16.
Yes. Thank you all very much indeed, and we hope to see you again soon. Goodbye.